Welcome everyone. Um, so far we have been working with booleans and we've seen some other extra things. So this time we're going to be looking at loops. So let's look at a real life situation, right? You wake up every day and let's say you're working, or if you're a student, you know that Monday to Friday are weekdays and these are days when you need to go to work or you need to go to school. So Monday you go to school, Tuesday you go to school, Wednesday you go to school, Thursday you go to school, Friday you go, Saturday no, Sunday no, Monday back to school. So you're continuously doing one activity and it might continue that way for the rest of your life. Not to be nihilistic, but this is an example of a loop that we are experiencing daily. So while you are still a student, you keep going to school unless you're notorious like I am and miss out on some days or most days. But also while you're still an employee or while you're still a worker, you're going to keep going to work because that's what you need to do. So we're going to be looking at loops in Rust and it follows the same construct. Are you a student or you are a student? That's a statement. If it's true, keep going to school. If it is not true, then you don't have any point going to school unless you are a teacher or unless you have some business to do in school. But let's isolate that for a student alone. So we're going to be looking at an example here, and we'll be looking for some way to loop statements or to loop expressions to loop activities in Rust. So there must be sometimes when you want to keep doing one particular thing or you want to keep following a particular procedure, a particular flow in your code, in your program, and you want to find out some way to do that in Rust. The way that we're going to talk about first is using conditioned loops. Conditioned loops. And the condition loop is represented with the while. Remember I said while you're still a student, you keep going to school. So let's introduce some fancy variable. If you work with some other programming language before, while learning, you remember the famous I. Let I equal 0, right? We know that I is originally an I32. And let's say while using jar, while I is less than or equal to, or let's just say less than 10, we are going to keep printing we're going to keep printing the value of I, right? So this is going to be a repeated process. As long as I is less than 10, we'll just keep printing I, and shockingly this is not going to have any end because we're just going to keep having zeros. Let's stop this here and let's change this to ln so you can see what I mean. Something's up with my keyboard. Okay, so printing this again. This is continuous, it doesn't stop, right? Now understanding this more, there needs to be something that should cause this to stop, and we could work with I, or we could improve I so that I stops continuously printing like we have seen, because these print statements here are quite long. You can try this out, maybe even slow on your computer. The way we can stop this is while you are still a student, keep going to school, but there's a time you stop being a student. That's when you graduate, depending on what level you're satisfied with. If you're satisfied with the bachelor's, you could just end there and you're no longer a student, so you have no more business in school. Or if you're going to school, your purpose for going to school is not because you're a student. So we could modify I to work this way. I will be increased by 1 every time that we run this. So let's modify I so it becomes a mutable variable, and let's change I because we know that we are not people who like failing. We're learning Rust for that matter, so we don't like failing, we keep going. So as a student, we never stop. So every time I goes through this process, it increases by 1, and if we print this out, there is an end to this program. 0, 1 to right up to 9, and we see that when I becomes 10, it stops because this statement becomes false. So let's break this down. First, I is 0, right? I less than 0, that's true. So we print I, increase I by 1. That's why we have 0 printed here. Then we come here, since I was increased by 1, the value of I now should be 1. 1 less than 10 is true. We print I, then we increase it by 1 again, becomes 2. Keep doing that till it finally becomes 9, and when it becomes 10, the loop stops. So this is the conditioned loop because it has a condition, I less than 10. Now with that, we can say we are quite okay with working with loops this way, and we could increase the value of I by 2. We could also increase it by 3, right? 0.396. Now there's a bad direction we could take where we could decrease the value of I by 1, and that way it never stops. So our conditioned loop we need to think about the loop before we start writing it, because we know that inevitably I becomes 10. That's why we are comfortably going to increase it by 1. If we know that the loop is going to cause something like an infinite state, we can introduce something to break it down. We can introduce something to stop it from going this way, or we could just decide to not do that. So I'm going to talk about something interesting here. So let's normally increase I by 1, but let's do something. Okay, while we are working with loops, there may be something we want to do. We might either introduce the word continue, which is another reserved word, or the word break, right? So while I is less than 10, if the value of I is, let me say that all this to be 1. If the value of I is greater than 5, I want that we should do something interesting, right? And that something interesting could be maybe printing out 5 times 10. Okay, so let's say if I is greater than 5, let's say print line I, not 5 times 10, I multiplied by 10. So we expect to see something like this: 0, 1, 2, 3, 4, 5. What's that's happening? We have 606. No, it's a bit of a problem there. Okay, so let's run this. 60, 70, 80, 90, 100. Okay, now we can want to do something to stop this loop by saying let's break this, right? What break does is it stops the loop from executing, and if I is greater than 5, we are going to stop this loop. Running this, we see that only 0 to 5 are printed, and that's because the loop stops at 5. Now what we also want to do is do some sort of a continue, but before we do continue, let's modify our program a bit by bringing this down here. Continue. If we run this with continue, it also stops here, right? Now let's look at the difference between break and continue. Break stops the loop based on a condition, or stop the loop wherever we write break, while continue skips the loop to the next part. We could say if I is greater than 5 and I is less than 7, right? On printing this, what happens to our loop? We see that the number 6 is not printed because the loop continued when I was greater than 5 and less than 7, and there's only one number greater than 5 and less than 7, which is 6. So we have seen that if we replace this with break, it doesn't matter, the loop ends at 5, and there we have the difference between continue and break. So what break does is exit early from a loop. When break is encountered, execution of the associated loop body is immediately terminated. It is terminated, stopped. While for continue, when continue is encountered, the current iteration is terminated, returning control to the loop head, typically continuing with the next iteration, meaning that whatever we are doing now, stop, do the next. So if you realize that this student is already so good in school at primary 6, take him to form 1, that is mid-year, right? While if this student is so bad, or it's not this type of student meant for school, let's break the student's school cycle and that student stops being a student. Maybe you see him prospering as an artist, right? It's musician, whatever. But that's real life explanation of what continue and break mean. So with that, we have played a bit with condition loops. We're not going to go further than this because we have to explore other loops. And the next we'll be looking at is infinite loops. Infinite loops are represented with a keyword loop, right? So we simply just have to say loop and provide a body. In this body, this statement here just continues to be executed. So let's get this off to clean up our console, right? And here we'll be working with the variable k. Let mute k, j. Let mute j be equal to 0. And we're just going to say print line j. Like we did the first time. This is going to cause a bit of a problem, but we like to explore, right? Continuous. And let's stop that. But by the way, the way I stop this is using Control C. Ctrl plus C, so some way to cancel it. Now by looking at this, we have just done exactly the same thing we did here. And what this does is it just continues to execute whatever is in this body forever. That's what the loop does. It's an infinite loop. Now we can modify this by saying j plus equals 1. So we increase the value of j in every loop, and it's going to be similar to the previous program, except it doesn't stop. Now the only way we can make it exactly similar is by saying if, right? Let's come up here and say if j is greater than 10, what do we do? If j is greater than 10, what we're going to do is break. So this, we have simply just made this into a while loop where we are going to break the statement if j is greater than 10. So I expect to see the values 0 to 10 printed to us without 11, and that's because 11 is out of range. Okay, now another thing we can also do is use continue, but I'll always advise you to have some break case in any time that you're using loop, because loop is infinite. So there may be some particular situation that you may have studied in your program and you've realized that it needs to stop happening here, because nothing happens forever unless some microcontroller program or some server that needs to continue listening for some requests, right? But most of our simple cases, we are never going to have some infinite loop. But once you notice that there is that part of your loop where you need to stop, identify it with an if statement and break. The next thing we'll be looking at is counting loops. Okay, so let's move from here, clean up the dirt, and head over to simplify this, bro, and let's start up with counting loops 4. So if you work with programming language like C before, you should have seen this for somewhere. And what for does is it counts over a range. And your similar construct, you may have seen this in another language where something like this, or int I equals 0, I less than 10, I plus plus, and you had somebody where you were running this. Okay, in a language like JavaScript, you may have had for let I equals 0, I less than 10, I plus plus, right? I'm not really sure if this is correct, but I guess so. So in Rust, we don't exactly have that. We have a simpler way of calling this, and for I in the range 0 to 10. Let's do this. Print line I. So immediately what I just realized, the number I falls in the range 0 to 10 and it automatically considers this as I32. So if we run this program, we expect to see 0 to 10 printed to us. All we have is 0 to 9. Now, what we expected was 0 to 10. So what we are simply trying to tell you is this statement is similar to 0 less than or equal to I less than 10. Why is it so? Rust takes the first number or the first item in this range and goes only to the last but one item in this range. That is why we have 0 to 9 here. So we have excluded 10, or Rust has excluded 10 because it is not within that range. If we want to have 10 printed out, let's just say 0 to 11. I'm printing this out straight 0 to 10. So this is a simpler and safer way of working with while and all loops. In our case here, we could have an infinite loop, right? Because the value of I could be decreased. And if it is less than, while it is less than 10, it's just going to keep printing. As for this, our break may never be executed if we do not design our program well. But in this case, we have a ranged loop, we have a counted loop. So it just counts within a particular range or within a particular sequence, and it works with whatever it has to work in that sequence. And in this sequence, you could decide to print 14, I by 4, multiply I by 14. What do you have? 0, 14, 28, 42 up to 140. So with that, now we have seen the various types of loops in Rust: conditional loops, while, infinite loops, loop, counting loops, for. Now that we have seen how we can repeatedly perform statements, we're going to be looking into sequences. And with sequences, we're not going to go far into it, but let's just end here for now. Thank you very much, guys. See you in the next video.